Hello and welcome to another lesson from Soflex Math. We are still in our division unit and we're working on yet another strategy. This one is called Hang 7. Some people call it Big 7. I guess it has some different names. So we're going to kind of show you how this one works. We're going to start out with some easy problems and then we'll work our way up to some longer division problems as well. Alright, so the first thing is the way it's going to actually look. So we're going to set up the problem. So our first one here of 83 divided by 6. So you can see how the start of the division sign is like the number 7. Well, that's exactly what we're going to do. So we're just going to bring that line down. So now I'll trace over this here. So you can see how it kind of turns into a 7. That's where it got its name from. Okay, and we're going to once again work with a couple of different words. So one is the power of 10 and the other one is compatible numbers, or numbers that are easy to work with. So we're going to try to solve this one using some mental math problems. So what we're really thinking here is, you know, how many 6's go into 8, and then how many 6's go into 83, or whatever you subtracted. But instead we're going to try to use numbers that we know. Numbers that are easy to work with are tens, hundreds, thousands, or maybe fives, or things that we can do mentally. So what we're going to start, we're going to kind of estimate here. I'm just going to start with the number 10. Okay, so we're going to kind of do it the same way. 10 times 6 is 60. So we're going to multiply that mental math problem and then subtract. So then we end up with 23 left. So now we're more working with a mental math problem. 23 divided by 6 doesn't work out even, but hopefully you can say, well, 4 is too many, so now we can just put a 3 here. And I kind of line them up next to where I'm working. So 3 times 6 is 18. And we're going to subtract again, and we get a 5. 6's cannot fit into 5. So our answer, we're going to just add up whatever's on the side of our 7. So 10 plus 3 is 13, and we have our remainder of 5. So the answer to 83 divided by 6 is 13, remainder 5. All right, so let's try another one. 61 divided by 4. So once again, we're going to draw the rest of our 7, so our big number 7. I'll trace over it again just so you can kind of see where that's 7. Same way, so now we could start with a 10 again, would be a good starting point. All right, because we know that 10 times 4, we know how to count by tens. So 10 times 4 is 40. All right, we're going to go ahead and subtract and get 21. And now, once again, we're closer to our fact families and our multiplication chart. So here we can take another stab at it and probably say 5 times 4 is 20. Remember, we're trying to get it even or perfect, but it doesn't always work out. Sometimes we have a remainder. All right, 1 is less than 4, so we're finished. So now I'm going to add those up again. So 10 plus 5 is 15, and we have 1 left. So our remainder is 1. So 15, remainder 1 is our answer there. So it's kind of like the estimation strategy previously, but now we're kind of writing them off to the side, and we're just kind of using some numbers like tens, and when we get to bigger problems, we'll be using hundreds and thousands. So let's take a look at a couple more examples. All right, our next example here is 453 divided by 7. All right, so let's trace over it again to see our big number 7. Okay, so this time we don't really want to go by tens because 10 times 7 is 70, but that's not even close. Okay, we could do 100, but we know 100 times 7 is 700, which is too big. So we can just think of our multiplication facts. So how many 7's can fit into 45? So we might say 6, but then we're just going to add a 0 to it. So like 60. So 6 times 7 is 42, plus we're going to add a 0. When we go ahead and subtract, we're going to end up with 33 left. How many 7's can go into 33? Well, probably around 4. Okay, and that's going to get us 4 times 7 is 28. Subtract again, and our remainder, our last number, is less than 7, so that is our remainder. So now we're just going to go ahead and add 60 plus 4 is 64, and a remainder of 5. So hopefully this is a new method for you, and maybe you like it or you're kind of catching on. Once again, you choose the method that works best for you. That's the way you got to choose when you do these different math problems. You don't always have to just solve it one way. Whatever works good for someone might work differently for someone else. All right, our next one, similar. So let's draw our big 7 to start. All right, same thing. If we do 10, that's only 30. If I do 100, that's too much, 300. So how many 3's go into 26? Well, let's try an 8, or in this case, an 80. So 8 times 3 is 24. And we're going to add our 0 from our powers of 10 units. Okay, we're going to go ahead and subtract. 5 minus 0, 6 minus 4. Okay, well, here I can use some previous knowledge. So if 8 times 3 is 24, 8 times 3 is going to be 24 again. So I can real quickly use a prior problem to help me with this problem. So I'll use that again to get a remainder of 1. So this one we can do as mental math. 80 plus 8 is 88. Remainder 1. All right, take a minute to look at those two, and then we're going to work on one with that goes into the thousands at their dividend. Okay, so this last one, we have 4,118 divided by 8. So tracing over, you don't have to trace over this every time. I'm just doing it to prove a point or to show you where that came from. So there's our big number 7. Okay, and now we're looking in the thousands. So if I chose 1,000, we know 1,000 times 8, okay, would be way too much. But what's half of 800? Or I'm sorry, what's half of 8,000 would be 4,000. So if I cut the 1,000 in half, I would have 500. So I'm just kind of talking through what I'm doing here. So 5 times 8 is 40, and then I have 2 zeros. So I end up with 4,000. So let me just talk through that again, where I came up with those numbers, because this is a way if you start thinking this way and thinking about numbers a little differently, it makes math really easy. So I knew that 1,000 times 8 is 8,000. So I know that 4,000 is half of 8,000, and I know that 500 is half of 1,000. So I basically just cut both of those in half. So that's how I could do that mentally. All right, so now look at how I've really made some headway here. I went from 4,000 something all the way down to 118 with just one first step. Okay, so I might now probably say how many 8's go into 11? 1 plus a 0, 10. So let's do an 80. And we'll go ahead and subtract. So 8 minus 0, 11 minus 8. Another thing, what I want to look at, you should be able to do 11 and minus 8 in your head. You shouldn't have to cross out this to make it a 0 and make that 11 again. So kind of think about numbers as we go too. Don't just kind of be like a robot following those. So we end up with 38. Okay, we got to keep going because 38 is bigger than 8, so we know we have to continue. So when this number is greater than this number, that tells us to keep going. So we're going to divide again. 5 was too big because that was a 40, so we're going to try maybe a 4. All right, which would get us a 32. And when we subtract that one, we're going to get a 6. So now I need to add 3 numbers together, 500 plus 10 plus 4. So that would equal 514. And then we cannot forget about our remainder at the bottom, remainder 6. So the answer to this one is 514, remainder 6. And just a quick reminder how you can check your work. So if you wanted to check this problem, you take your quotient, so 514 times 8, get that answer, add 6, and then you should come up with this as your new answer when you check it with multiplying. So you can always do that no matter what method you're trying. That's always a good thing to practice. So once again, ask questions in the comment, and we're going to move on. Next lesson is going to be double-digit divisors, which is always a little bit tricky because it takes a lot of steps, and it's easy to make a simple mistake, and then you have to kind of start over. So join us for our next lesson from Soflex Math, working on double-digit divisors.